How many of you people out there are using Node like at work right now? Yay! I found the Node people at the fancy server conference. I'm really happy. Thanks all for coming. How many people are doing primarily front-end JavaScript stuff in your work? Lots of people too. Great. So if you're not using Node on a daily basis, some of the things I talk about today will still be useful as long as you're doing JavaScript things. And so I hope that you find this useful. I'm really excited to dive on into it. So my talk's called Building Scalable and Dependable JavaScript Applications, like she said, showing how to use Node and JavaScript responsibly. The way that I want to start this is by talking about a bug that we had at PayPal on, I work on the Send Money team primarily, about a year ago. And I'm going to call it the mystery of the missing stack trace. You will see why in a second. So normally when you have a crash in Node, raise your hand if you've had your Node servers crash in production before. Yeah, a lot of people. This is a common problem with Node, and it's kind of like normal and OK, but it's also not so OK. So it looks like this. It looks kind of like this. You'll have some sort of stack trace, and that's fine. But at PayPal, when we get a crash on our servers, they'll send us an email. They'll say, OK, we pulled this out of your error log after your crash. They'll send us an email telling me what server crashed and how many times it's crashed. Works pretty well. But in this particular bug, in this particular case, the emails were empty. There was nothing there. We had no idea why our app was failing or where it was failing. And so I want you to stop and think for a second. You know your server's crashing. You have no stack trace and no information. What do? Anyone? Throw out ideas. What do you got? Perfect. That's exactly what I was thinking at the time, too. I was just like, what can we do? So, we can look at a diff between the broken code and the working code. We can try to find other logs. Like maybe there's nothing in the error log, but there may be some other log that has some secret information for us. I don't know. System metrics might be helpful. So if you see our CPU spiking or memory's going crazy, that could be telling of a certain type of problem. Typical JavaScript answer, you can just console.log everything. And of course, there's fancy techniques, postmortem debugging, heap dumps, this kind of stuff. It's more advanced. It's less common, but it's pretty helpful. So anyway, we tried some of these things in this particular case. We looked at the diff of the code. There wasn't anything obvious. We couldn't see anything that should have been wrong. But looking at the access logs was really telling. So we noticed that shortly before the app restarted, there was, we were hitting this page, our request money page. And there was no, again, we couldn't figure out why the request money page was being so evil, and we couldn't reproduce it very easily. But once we were able to at least narrow down the where, we were able to start thinking harder about the why. So once we had that in mind, OK, this is what's failing, we started diving into the code, and we found some funny stuff. And we tried at first, commenting out things, console.logging things, the really tried and true JavaScript debugging techniques, and none of that worked. Finally, we started putting on our thinking caps and thinking a little bit harder about the code. So let me walk you through this handle request function we have. So when people are requesting money, we have a lot of important logic. And then we send back a request ID saying, OK, your request is complete. And then we have this funny thing at the bottom. And this is, for me, I'm always obsessed with patterns and code smells and things that are not the normal way we do things. And this is really weird to me, because usually after a res.send or a res.render or a res.json, we're done. We don't do anything else. But for some reason, we have this bright idea to say, OK, after the request is totally successful, we're going to, if we're sending to a known sender or requesting from a known sender, like an existing PayPal user, we're going to opt them into this special experience. We're going to do a little bit of extra work there. And this, again, this code hadn't really changed. There's nothing in the diff that looked particularly suspicious. But we figured it just seemed so wrong. So we dove into it a little bit more. And I want to just dive into this function. So we have our opt-in to experiment function, takes in the sender ID. We then decrypt that. We get our encrypted, I guess it's our decrypted ID, sorry about that. And then we take that ID, we pass it to the add user call. And if there's an error, we call our special logger function to log the response from the service. OK, here's the thing, folks. You were probably thinking, I don't know, looks fine, right? Anyone know what's wrong with this code? What was that? No, the other code is good. Everything else is fine. Yeah, res is here. Maybe it doesn't exist. OK, fair enough. Good intuition here. What was that? Hey, OK. This is where things are getting interesting. Turns out we had recently changed our decrypt function to return a promise. Here's the thing about diff and GitHub and all this. When things change, we can't track like the other things that changed very well. So we see like nothing changed in this function. We're fine. But it turns out someone changed decrypt somewhere else. And for a number of reasons, the way that we had mocking set up on this service, our tests didn't fail. They just kept working because we were only testing the happy path. Oops, it happens, but it was really annoying. And this bug was like 3 days. Me and my colleagues were like trying to figure this out because it was crashing all the time. It was driving us so mad. So the decrypt function was updated to return a promise, which is cool. Add user, of course, expects a string. And then problem number 2, this log function, which is this thing I wrote 4 years ago. It was like the first thing I did at PayPal. I'm like, our logs are ugly. I want to pretty print our logs with fancy formatting. So I added some fancy formatting, but it only expects like a little error message and like a little stack trace and maybe like a service code or something. It was going to make it look really nice. But then the thing is, I'm logging res, which is the HTTP response object. And that, if you're not familiar with that, has this many properties. I tried I tried print all of them, and I had to like not include all of the images because it started making Keynote slow. And a lot of these things, they point to each other. They have all these like internal dependencies pointing at the other one. So if you have like this really rudimentary log function that you wrote like in an hour for fun because it didn't seem like a big deal, it will just go over every single one and basically infinitely loop. And it turns out it ended up taking about 45 seconds before the thing completely just destroyed our server. And the process monitor eventually just killed that process. Oops, we make a lot of mistakes in JavaScript. But this bug really taught me a lot. It got me really excited about making less mistakes in JavaScript. And so I kind of got a few ideas, and really the inspiration from this talk came from this bug. So one, we need better static analysis. It would be cool if we had the programming, like the code, the build tools, the CI, someone else could tell me this was broken before production. That would be cool. 2, we need better debugging tools. Throwing up like console.log garbage in production, like this is not good programming. 3rd, like consistent way to handle errors. We sort of had a pattern, like I had the fancy logger and stuff, but I'll show you some specific ideas of how we can handle errors consistently so that they're done better. And then our logging and monitoring, I mean, you can tell this is a bit amateur hour, everything I described here, and hopefully since then we've learned to do a better job. And I'll show you how to do that today. First, we're going to talk about flow type and ESLint. How many of you are using either TypeScript or Flow? OK, I will say about 1/3 of people here. I will try and convince you now that it's a good idea. Type checking could have caught that bug with 2 lines of code. 2 lines. And it took me 3 days, me and a colleague. We were spending 3 days trying all sorts of stuff, trying to figure everything out. And when I realized we could have caught this so simply, I really was like, I'm not going to not add types to anything that I care about not breaking, because it's so simple. So let me show you this code. We have our opt-into experiment function. We just need to tell it that this encrypted ID, which is actually the decrypted ID, should be a string. OK, not very hard. Colon string. Not so bad. People are like, I hate it. It's like not JavaScript syntax. It's like, it's some metadata. Just some metadata. It's not so bad. It doesn't feel bad, especially when it saves me days of time. And then the second thing is our decrypt function. We just need to tell it that it returns a promise. That's all we have to do. Not so bad, once again. And if we do those things, then Flow will say, hey, cannot assign decrypt to encrypted ID because promise is not a string. It's so nice. It wasn't very hard. And so I will challenge you and encourage you to start looking at types in JavaScript. If your applications, if you don't want them to crash, especially on the Node side, I know there's a bit of hesitation around things like, well, what about I don't want to use Babel, or I don't want to transpile, blah, blah, blah. It's like, I don't know. I don't want my apps to crash. So I'm willing to try some tools that will make my things work better. As far as like Flow versus TypeScript, any Flow people here? OK, nobody's using Flow. Oh, wait, one person. What's your name?
Anyway, I want to chip to TypeScript.
OK, whatever. That's fine. I'm not selling you anything. It's cool. I was going to say, Flow and TypeScript are great. Flow has gotten a lot of flack for bad error messages. They recently shipped a new version with better error messages. but use whatever. Like, they're both great. Both of them, I think, are equally good. Maybe have slight different pros and cons, but they're both like miles better than normal JavaScript when it comes to having built-in static analysis. Good stuff. So again, I'll show you a little example of how to add some types to your JavaScript and hopefully get you feeling OK with the idea. Again, we just don't want you feeling uncomfortable with things that are going to make your app better. So check this out. I have this eatDonut function, and you'll notice at the bottom the parameters order is switched. So I'm sending the person second, or first and the donut second. They should be the other way around. No big deal. So if I want to start adding flow to this, I'm going to add a little flow comment thing. And then I can say donut should be a donut, person should be a person. Of course, it doesn't know what that is yet. So then I have to say type donut equals, here's like a flow style enum. So I can just say a donut means one of these three strings, maple, chocolate, or glazed. I know there are other donuts, okay? I'm familiar with donuts. I live in Portland. We have a lot of donuts in Portland. It's very common to have donuts there. They're very good. But for the purposes of the example, I only want to show 3 kinds of donuts. For a person, you can just use a normal ES6 class. And it's like, it'll use that. But if you want it to work a little bit better, you can add and say the name instance variable is type string. It's not so bad. And if I do those things, then Flow's smart enough to say a person is not a donut. It works very well. It's smart. Jessica likes all my jokes. I love this so much. She's the best track host. If you ever are going to be speaking, get her to be your track host. She will be incredibly supportive. I'm really grateful. So let's talk about linters for a second. How many people are using ESLint in your code? What about like any other linter tools people are using like that they're pretty excited about? Standard. OK, standard is actually based on ESLint. So that's perfect. Standard is great. Love standard. I've contributed a bit on standard before. So previous to having this whole terrible bug that made me obsessed with types in JavaScript, I was like really a big fan of ESLint and linting. And I want to show you one of the like architecture challenges of linters. So I'm going to give you a super quick overview of how linting works in JavaScript. And how many of you have written a custom ESLint rule before? Yes. Yes, that guy. That's so cool. OK, this is my favorite thing is writing custom ESLint rules. And if you would have caught me like 3 years ago, all I was doing is going around giving talks about how to write custom ESLint rules and how ASTs work. And all this stuff's really exciting. But for today, I'll tell you about this. If you're having ESLint look at your code, it's going to go through each JavaScript file that you pass it. It passes that through a parser acorn, converts that to a syntax tree. Now, abstract syntax tree is just like a big JavaScript object that has all sorts of metadata and information about what your code is doing. So it'll say, these are all the statements and functions and things, and these are all the parameters. It's just like a giant JavaScript definition of what's happening in your code. And then ESLint will pass that to all of those rules. And each rule just takes in one of those trees, those syntax trees, again, that JavaScript object, and like queries it and says, OK, how many parameters are in each function, is each function taken? And maybe they've gone over whatever limit. And you can write a rule in ESLint in 5 lines of code. Like max params, that rule that says you can only have like 3 parameters to a function or whatever, you can write that rule in literally like maybe 7 lines of code. They're very, very small, very compact. It's an amazing architecture. But it has this huge, huge flaw, which is that linters only think about 1 file at a time. Now, you're probably thinking, that sounds fine. I don't know. I don't think about 2 files at the same time, but you do. See, you think about them because when you're pulling in another file, you care what that file is bringing into the other file. So type systems are a lot smarter. They think about your whole JavaScript ecosystem at the same time. Let's look at the flow. This is like a really bad diagram of Flow's architecture. And I never asked anyone that works on Flow if it's actually how it works. It's my understanding. But I think for the point, it should be acceptable. So Flow basically reads all your JavaScript files. It looks in your node modules folder. It looks under your covers. It looks in your shoes and your closets. It grabs all the JavaScript. It grabs JSON files that it can find. It does, like, it's kind of annoying at how much it tries to read into everything. And then it pulls out all the types, relationships, any information, oh, that file is going to be exporting a function that returns a string, or that variable is set to a number, so I'm just going to assume that you want that to always be a number. It does a lot of type inference. It takes all this information and sticks it in this like graph database server running on your computer. So if you're using Flow, it's having like 6 servers running in the background of your computer all the time, having all this information about all the types in your whole JavaScript world. And then, then when you go into a particular JavaScript file, it will consult that graph and say, OK, you're pulling in this function from that file. Yeah, well, that is going to give you this type of variable. So it's able to make really intelligent decisions about types and how you're correctly or incorrectly using them. It's much more powerful than a linter. So I think they're both really helpful. And I started wondering, like, could a linter have helped us with this mystery bug? What do y'all think? Would a linter have been good enough to solve this problem? OK, I see people shaking their head, but they're like, you wouldn't ask the question unless you probably already are going to have some kind of tricky answer. So here's the thing. You can do something. Like, I could say, well, there's some code smells here, and I can lint for that. So like, I could say, I could really easily write a rule in ESLint that says, I don't want to have any statements after I call res.send or res.render. OK, that's something you could do pretty easily. I could also write a custom rule that said, hey, if you're using that logger.log function, make sure that the variable isn't res. I mean, these are kind of like I'm grasping at straws here. Like I could write a rule, a specific rule for my team, and this is something I do a lot actually. If I notice that my team is making the same mistake, like more than one time, more than 2 times, or if I'm making the same mistake over and over again, I can very easily write a custom ESLint rule that says, hey, let's not make this mistake anymore. And then that bug ceases to exist in our system. So linting still has a place. And I'll just tell you, we actually use ESLint to enforce that people use flow type. So there's kind of this weird nature. They're all kind of friends, all these different tools. We also use Prettier to enforce styles. We're not using ESLint to do our style checking, which is, I think, the 95% reason people use ESLint. We're actually using flow to check our types, ESLint to check for other bugs and custom rules that we write, and then Prettier to format all our files for us. That's a lot of stuff. That's a lot of static analysis, but I think it's really good. And I think everyone needs to up-level in their static analysis skills. And even if you get away from this and say, I still hate types, we'll get better at ESLint because you can do some great stuff with it. Now, unfortunately, even despite all of that wonderful, amazing stuff that we have there, we still get bugs in our code, which is really depressing. And that's why I want to talk a little bit about debugging. Now, I'm curious out there, does anyone have any secret good debugging skills? Like for production debugging in Node, what are people using? Anything good out there? What is it? OK, yeah, so there's basically, this is a great point. The silence, I think, proves the point. The debugging Node in production is really difficult. And so everyone kind of has heard probably about when Node 6 came out, they announced this support for using the Chrome debugger. Oh, sorry, I skipped that. Yeah, they announced support for using the Chrome debugger. And so it was pretty cool. You could call node-inspect or node-debug or whatever the flag was, and it will open up this debugger, and you can do debugging the similar way you do debugging on the web. And it worked for Node. And of course, there had been previously other tools for that, but they were sort of limited. What Node 8 came out with, which, as far as I know, I've never heard anyone talk about it before. Just sort of like one of my colleagues, James Charles, stumbled on this as we were struggling with debugging at PayPal the last couple months. And he figured out that there's this new inspector module. And the inspector module allows programmatic access to the V8 debugger from Node. So within my app, I can actually poke into that V8 inspector and turn it on and off or even manipulate it in other ways programmatically. It's really powerful. So first thing we did is we set up this debug mode. So on any of our staging servers, we have this special route. If you just add /debug at the end, we can just turn on Chrome DevTools on our staging servers. Not anything local, but something on a staging server that we're testing on. And we just click connect to Chrome DevTools. And then we add our host name into our Chrome DevTools. And it will allow us to do all sorts of cool stuff, like set breakpoints and pause on uncaught exceptions, pause on caught exceptions. You can even do other things, like when it does get caught, you can see there's a really good stack trace. Like a normal Node stack trace looks like this. There's just a few lines. It sort of has this async barrier. So anytime you do a set timeout or process.nextTick, anything you do async in Node, your stack trace basically usually gets cut off. But with Chrome DevTools, you get this really, really nice long stack trace, as you can see on the right there. And it shows exactly what route had been called and all this stuff. It's really powerful. You can even do, let's see if I can get this to work. You can even hot reload your file. So our process for updating our stages right now at PayPal or historically has been pretty rough. You'd have to go create a new build, send that up to a stage. It could take half an hour to do a new debug build, and that's something that we're just sort of used to. But with this, I can hot reload a change on stage immediately in seconds. It's amazing. And as soon as we got this working, Jameis and I threw this thing together for a hackathon. We won the prize. Hooray! And people were super impressed. And we're like, we need to put this on production today. And yeah, you can't do that, actually. For two, at least, really good reasons. One, imagine you're having like 50 people coming to hit your app, and you're like, oh, we'll just pause on this breakpoint and just wreck all those people's connections. That's not going to work. And two, we're having like random engineers just being able to pause on production and be like, what financial information is coming through our system right now? Like, we can't do that either. So we talked to our infra people, our security people. Everyone was like, there's no way. You're not allowed to use this stuff. And we're like, but the experience is so hard right now. Like, debugging, like, this will be amazing, and we'll be able to catch bugs, and we'll be able to fix things, and like, I can update something. And they're like, you can't have random people just like hot reloading code in our production server when we're handling financial data. Like, you can't do it. So I was really like, I was sort of gutted, because I'm like, we figured out like the cool futuristic way to do debugging in Node that no one is using, and it turns out we can't actually do that, which is depressing. But I will say, there is something good that you can do. So along with the inspector module call is something called inspector.session. Now, you're thinking, what is that? I will tell you. So with inspector.session, you can open up a session into the V8 debugger from your app. Now, before you'd be opening that session from your dev tools on your computer, but here you're actually opening it from your app, and your app can communicate and get all the debugging information that was maybe going into Chrome DevTools, but you can just get it in your app and do interesting things with it. And this we can actually do in a controlled way without some of the security and other implications that we had of just letting engineers just hit pause breakpoints in a production server. Let me just I'm not gonna like go into it forever, because y'all are gonna have to look this up and do a little bit of digging yourself. But imagine you create your new session, you connect, you then have to say, I want to be able to use the runtime and the debugger. It's kind of a weird protocol, but it's just whatever your Chrome DevTools is doing under the hood anyway. Then you can say, oh, I want those fancy async stack traces. So you can set async call stack depth. So all of a sudden, instead of getting your 4 lines, you can get async stack traces that will let you be a mega fast debugger. And then you can say set pause on exceptions. You can give it all exceptions, uncaught exceptions, whatever you want. And then when the debugger pauses, you get access to the call frames, the reason, the async stack trace, all of these variables. You can do all sorts of stuff with. There's all sorts of documentation. There's this DevTools protocol viewer that you can look at the docs. It's kind of like Java doc style. Maybe that's popular among enterprisey folks. I don't know, but it's pretty easy to read, and it's very helpful information. And with it, I was able to quickly throw together this. So we've got our default node error message on top, and down on the bottom with I will say 10 or 12 lines of code, I was able to both reproduce the original stack trace, which is at the bottom, and then add all the cool async stack trace bits in a format that basically looks like that. So here's the use case for this. Imagine our servers are crashing, and I'm really sad. Maybe I can go turn on, just hit a special route, or have some way to turn on like verbose crash logs, okay? I just want to enable them temporarily or enable them on a specific box. So I turn on this verbose crash logs, and now anytime the server's about to crash, it spits out all this good information, so I can actually figure out where it happened faster than the 3-day benchmark I set the first time we had a really bad crash attack. So I'm pumped about this thing. We haven't started doing this in production yet. We are using other stuff in staging, but I'm really convinced that this is going to open up a lot of cool doors for us. We're also looking at nSolid and some of these other tools, but I actually think this is the way forward. And we've talked with some folks on the V8 team who told us that it won't slow down our app to start hooking into some of this stuff, because it's already built in. It already has, like, all those hooks are being called anyway. So in general, it's not going to add a lot of overhead, though we'll still need to benchmark it and test it to make sure. Final point on this. You need to find a debugging approach that works for you and your team. Console.log doesn't cut it. You need something better. Here's a suggestion. Check out this inspector module. Maybe there's something else that will work for you, but be ready before the bugs start coming to figure out how you're going to debug them when they come again. OK, that's a lot. I'm just going to pause, because I'm kind of worn out talking too much. Any questions or anything, any comments on that section? I want something, yeah.
Don't use any tools like App Dynamics entry.
Do we use tools like App Dynamics? Sorry, what was that, Jessica?
I was going to tell you to repeat the question, but
Yeah. Do we use tools like App Dynamics? Yeah, we've explored using App Dynamics and, in fact, have had some success with it. Personally, I like tools that are really JavaScript focused. So like I mentioned, we're also looking at InSolid right now. And InSolid has a lot of like heap dumps and performance profiling stuff. It's really a good tool. But I haven't found anything better than what I showed you for just everyday debugging like crashes and the types of things I deal with. Anything else? Any other questions? All right. So we've covered basically how to debug when unexpected errors happen. What I want to talk about now is how we deal with those expected errors. So, you know, like you have an API, but someone didn't send the right type of parameters, or you're hitting a service and the service is down. Like these things, we know these things. They happen. We can expect them. But we need a plan for those expected errors. The way that I'm going to demonstrate this is with the way that we're currently using async-await and how we're hooking that into our error handling. I think it's really nice, and it will be hopefully something new and exciting for you. How many of you are using async-await in your Node apps today? Oh, wonderful. So many people. Then you probably already may have discovered this stuff. The good thing is I'm not going to talk a bunch about how async-await works. I'm just going to go quickly into the stuff we're doing for error handling. Hopefully, it will be helpful. Quick recap. So an async function in JavaScript, and this is available in Node 8, so if you're using Node 8, you can just use this stuff without a transpiler. If you're using something earlier, you can use Babel. An async function is basically the same as a normal function that just always returns a promise. So if you have async function getNumber and return 4, it's basically identical to this function getNumber return promise.resolve 4. So just remember, if I'm using an async function, it always returns a promise. Now, here's the interesting thing. The same goes for errors. So if you throw or have an error inside of an async function, that gets converted into a rejected promise. So it's just like promises under the hood everywhere. So these two examples are basically equivalent. I can throw in an async function, or I can return a rejected promise. Essentially the same thing. Now, if you throw in normal callback land JavaScript, your app will blow up. But in async land, in async-await land, you're pretty safe, because it just returns a rejected promise, and you can handle that promise later. So we've sort of discovered, and I think it's not like we discovered, but we've been using lately this pattern that we're called async middleware pattern. Because I was like, I want to use async-await. I want to figure out how to use it, but we're using Express, and we're using kind of typical Express middleware. So we're like, how do I merge those two worlds? They're very different worlds. So the first thing that we did is we started just saying, OK, like let's just have async functions, and then I can say, for example, if I converted our getUsersForID function from a callback to a promise-based function, I can just await that function. Now, getUsers will pause until the users come back from that service, and then I can render this out. I think it's really, really clean compared to the way we were writing callback JavaScript. But I'm not here to talk about how async-await makes your apps clean. I'm here to talk about how to do error handling with it. So here's the problem. If there's an error in getUsersForID, the errors will bubble up to the top, no problem. But we don't actually catch the error. So down at the bottom in our Express side, Express is going to get this unhandled rejection, and it will crash. So we have to do something about that. So after playing around with this for a while and realizing, oh, we're crashing all over the place, even though I'm telling everyone, like, hey, better error handling with async-await, it just magically bubbles. Turns out it's not all magic. You have to add some error handling or a catch somewhere. So we did this thing. We made this little handle error function. I'll walk you through it. It's not very hard, but it's kind of interesting. So first, you pass in your async middleware or your async route to that function. You then return sort of a standard middleware, that recResNext function signature. And then when that middleware gets called, you execute your async middleware. And the only special thing you have to do is catch any error. So it'll call your async middleware, and then if those throw, it'll catch the error and pass it to the Express error handler. Does that sort of make sense? I see like one head nod. I'm just going to call it good. So then you have to wrap your routes with it. Here's the problem, though. If you forget to wrap your routes with it, like we do, like let's say we had getUsers that had it wrapped, and then we add an authenticate method, which was also asynchronous. we're like, oh, that's fine. But no, it's not fine. It will also crash. So this became this problem, like this whack-a-mole problem. We're like, OK, someone added a new async route, or we converted this new flow to async-await, and we forgot to wrap with our error handler thing. And very quickly realized, like, this is not a good plan. Like, I have created a monster here. Like, I thought that it was going to be so nice and so perfect and everything was going to be easy, but actually it's not easy when things crash, and it's very difficult to trace why, and it was very sad. So we need to make it easy for the engineers to do the right thing with regard to dealing with errors. So that's when we figured out what we could do. Instead of making users wrap their routes in like an error handler or add try catch all over the place, you can actually like hijack the express like the express like app.get, app.use, app.post, all those methods, and just add async support directly into those methods. There's a huge thread on the Express.js like issues page where people are like, add support for promises or async middleware, and they're like, we don't really want to maintain this. We don't care. We're never going to do it. We're never going to do it, more or less. And so a lot of people have come up with things like this one, Express.js async errors, which will just patch the Express to support async middlewares. And this is what we do. We don't use this particular module. We've written our own in-house, but it works super well. So now people can throw however they want, and it'll just be caught really nicely. The other side to this error handling, I don't know, the other side to this coin, I don't know what it is, but the other part of it that I want to discuss is custom error classes. This is something else that we use a lot that I think is really effective. I'll show you how it works together. So with async-await, we can do something like async function get card. And if you don't have the parameters, if you're missing a parameter, we can throw a new error, missing ID. This is actually fairly clean. And unlike in normal callback land Node, this won't crash. This will be properly handled and caught, and it works pretty well. But we've sort of moved to something like this. Instead of calling new error, we'll have new param error, or just whatever custom error type that we create. And that param error can encapsulate some special logic that allows us to do really interesting things. Let me show you an example. So here I have my param error class. With ES6 classes, it's super easy for us to just say param error extends error. Then it just gets all the built-in error stuff very easily. It's nice. Before, when we were doing this with like old JavaScript ES5, it was like lots of weird object.create and stuff. We don't do any of that anymore. This is really cool. And then I just call super missing param, whatever field name I passed in. The second one, error capture stack trace, is actually not essential, but it'll help us have a slightly cleaner stack trace. Because it already extends error, it's going to have a stack trace anyway, but this will clean it up in some ways. And then let's say we want to add a status code to this. Now you're probably thinking, why would I add a status code to an error object? Well, it's a parameter error. And so missing parameters, you might want to give that a status code 400. There's probably like a better status code. This is just an example. So then in my like default Express error handler, I can say something like let status code equals error.statuscode, or just the default 500 if I don't have one. And then I pass that along, pass in the error message, or whatever. Obviously, we could do something fancier if you want. Now you're saying, you could probably think, I don't need a custom error to do that. Like, sure, you could ask people to write this. Like let error equals new error, error.statuscode equals 400, throw error. And a lot of people do stuff like that, but I find it's just way cleaner to encapsulate that inside a custom error class. It works pretty well. So check it out. Those two things combined have worked really well for us. So using async-await, just throwing errors, feeling really good about doing that, and then using custom error classes to, I don't know, make it a little bit easier to encapsulate stuff. So we use those error classes to handle localization of error messages, because PayPal supports a lot of countries. So we've got to do that at some point. So we wrap that into our base error class, and it works pretty well. So yeah, that's a little bit about errors. Any question about handling expected errors, async-await, anything like that before I move on? Good, I'm glad you don't have questions. That means I'm doing a super good job explaining it. So I've gone over a lot of stuff so far. I want to talk now about client-side errors. How many of you are doing client-side monitoring in your apps, or client-side error monitoring? A couple people. Hopefully by the end of this, you'll all be completely convinced that this is a very important thing to do. So when you're handling, well, first of all, why is this important? If you look at this example, here's an example of our send money page that I work on. Someone trying to click it, and they're getting an error. How many times are our users out there trying to do something on our page and it doesn't work. But we never hear about it because most of our monitoring and logging, like at PayPal, it's all set up by our server people who are thinking very much about what status codes are coming in and what's happening on our servers and what's the load like on the servers. They're not thinking about what's happening to our clients. But if a customer client can't click on something, it'll never send an AJAX call. It'll never necessarily fail in any way that we can measure that on our end. The actual error is hiding right there in the user's DevTools, which they're never going to open in a million years. I guarantee it. They don't know what's wrong. And so one of the big things I worked on in the last year was trying to really figure out how to solve this problem. How can we get information about what's failing in our clients, and how can we get that into us in an actionable way? So browsers ship this thing called window.onError. It's well understood. Now most browsers support actually sending an error object with stack trace and all that good stuff. But because the implementations are different across browsers, usually your strategy is you listen for window.onError, you clean up that data, and then you can post that to your server with AJAX or this navigator.sendBeacon or however you want to do it. And then you'll see at the bottom we're using Grafana to just sort of graph how that changes over time. And Kibana, if we want to dive in and look at stack traces and all that stuff, we have a lot of different tools for monitoring, and we finally put client-side errors in there. So this is the mystery part. Okay, so we added client-side monitoring on our team. We figured out there's some tricks to it, by the way. If you want to get it to work and your code's on a CDN, you have to use cores on your script tags for it to be able to read the stack traces. There's some funky stuff. Once we got that working, though, we deployed some code a couple weeks later, and we noticed this big spike, huge spike, like thousands more errors or hundreds more errors during our deploy. And initially, we're thinking, okay, this is so good, actually. We're amazing because we figured out that our new system for tracking errors is working. I was taking credit for it because I know I didn't build the code that was crashing. I was building the part that was tracking the errors and alerted us to the problem, so I was really proud of myself. And then we actually looked into the bug, and it wasn't as cut and dry as it first seemed. So here's the problem. The bug looks something like this. Unexpected token, angle bracket, in JSON at position 0. Anyone know what that is?
Trying to parse HTML.
Trying to parse HTML. OK. Why would this be happening? Let's assume I could never reproduce this outside of a deploy event. Why is this happening? We tried. We saw this is the error message. Why? That doesn't make sense. And we reproduced the route 100 times locally or on production environment. Yes. So essentially, I'll tell you what happened. Something like that. We're not getting the data correctly. We have a lot of servers, right? PayPal, the Send Money app has between 200 and 400 servers running its Node app. They're not all taking live traffic, but we're ready for massive scale. So we have a bunch of servers out there, and they're spread across different data centers. When we deploy, we sort of go half the data center, and then the rest, and then we sort of pause and say okay, is everything looking good? And then we carry on with our deploy process. We go to another data center. We start rolling out. We could keep checking things, complete that data center, and move on. Here's the problem for us that we didn't know before. That leads to a situation where your UI code might be coming from server version A, and your server code might be coming from server with version B of the code base. And so in this particular case, oh, and by the way, our sessions are sticky per data center. So if they're sticky for a particular server, we'd be safe. But because they're sticky per data center, there's a chance that a data center has half code A and half code B. And so we're getting the UI code from one. So the UI code is saying, hit this route, hit this JSON route. And it's hitting that route, and it's getting a 404. It's returning an HTML message. And that message is trying to parse that JSON, and it's failing. Here's the part that really stung me, because I was so proud that at least I built the error handling thing, so at least I was able to detect the problem. Well, here's the issue. Here's when we decided to roll back. It's that yellow line. The process of deploying or rolling back both triggered the same bug. So it wasn't actually, the issue wasn't actually that anything was wrong in our code. The problem was that the deploy process was hurting our customers. Now, we were never monitoring this before, so we didn't realize that anytime we rolled out with a breaking AJAX change, we were hurting a bunch of customers. Any customers using those change routes could potentially be affected. And it turns out, whether we're going forward or backward, the process is still basically exactly the same. So that was a pretty interesting learning experience, a frustrating one. We talked to everyone who was saying, we need to change our deploy process, everything's terrible. And they said, well, don't you know you're supposed to write backwards compatible code every time you deploy? Like, I never heard of that before. I never thought of that before because I never worked on a system with 200 servers that took, so long to roll out across all these boxes. Apparently, our service people had always been doing this, but the Node people were used to doing things in a different way. We just hadn't considered it before. It was a fun bug. So we learned a bunch of stuff from this. Obviously, UI monitoring is a huge blind spot. There's probably better tools than writing one in-house. There's Track.js and other tools out there. I highly recommend, if you care about not hurting your customers, to check it out. And of course, think about how the deploy process is affecting your users. We didn't know until we had this UI monitoring in place that it was affecting our users. Every single time we deployed, it was hurting our users. We didn't realize that. Or every time we deployed with a breaking change like that. And of course, one thing that this really made us think is that maybe we should actually think harder about separating our UI and server deploys. We'd always kind of been like, no, we're a Node team. We're sort of the front end of the front end and the back end of the front end all at the same time. And maybe there's actually some nice thought into saying, let's version our APIs, and let's do that on the Node side, and let's have our UI code deploy independently. So we're still kind of discussing the best way to handle deploys of our front end assets, but I don't know, just some food for thought. I hope that gets you thinking about maybe this is happening to you, or maybe you're already preventing this in some way. I don't know. So let's conclude this long-winded discussion about building dependable and scalable Node apps with just a few points that I'd like to emphasize. The first one, use static analysis, especially types. Types really help to catch those bugs early. But if you really don't like types, at least get really comfortable with ESLint, not just for style rules, but understand how to build custom rules so that if you see a bug happen in your app, you can make sure that bug doesn't ever happen again. The next thing is have a plan for debugging. I presented one plan or one strategy, but there might be a different strategy that works for you and your team. It depends. But at least have a plan in place before the bugs are coming so that you know what you're going to do, how you can quickly get the information you need to solve that problem. 3, have a consistent approach for error handling. I really feel like this is important. Errors happen in our apps all the time, and most of them are expected errors. So figure out how to be prepared for those expected errors. Document the process. Okay, if we have an error, we always call back with an error object that looks something like this shape. Just have a plan so that every single time, and again, when you have a pattern that you want to enforce, you can write a lint rule to say, we're only going to accept errors that happen in this way, or however you want to do it. It makes it easy to enforce, and it makes it easy for code reviewers to say, hey, I don't think you're doing this the right way, if you have a consistent approach. Of course, make sure to access all the logs. The first bug I was talking about at the very beginning of this thing was the missing stack trace. Turns out, I only found this out a couple weeks ago. The stack trace, when our error crashes because of a resource limitation, which is what's happening, the server was spinning, the process monitor, PM2 that we have, actually closes that process. And the stack trace for that lives in the PM2 logs, not in the app logs. I didn't know that before, but it turns out there's a bunch of other logs other than the app logs that might have useful information for your app. So make sure that you know where everything is, what information you might need, and do your best to have, hopefully your system will correlate and put all that stuff together. And finally, don't forget about those client-side errors. They're pretty important. They can speak volumes to what pain your customers are experiencing, and they can help you build, of course, better apps on the server side. Thank you very much.